So our warm-up says to graph y equals x squared. X squared means you plug in a value for x and then you square it to get y. So if I plug in 0, I get 0. But if I plug in 1, I get 1. If I plug in 2, you get 4. If I plug in 3, 9. And then there are negatives also. If I plug in negative 1, I get positive 1. Negative 2, positive 4. Mirror points. Now, does this function have an inverse that is also a function?
I don't remember how to do
Yeah.
The correct answer is no.
it.
Who can tell me why?
It doesn't pass the horizontal line.
Does not pass the horizontal line test. Now, can I manipulate the original question so that it would have an inverse? Could I take y equals x squared and give it a restriction so that with the restriction it would have an inverse function? We did not spend a lot of time on this before. So if I were able to give this a restriction on the domain, if I were able to only use certain x's, do you know? Not exactly. That has to do with the domain, but this doesn't have asymptotes, so it wouldn't be that. What?
Right, it's just only positive.
Almost totally right. I'm going to start here, which isn't a positive number.
Okay, where
But-
x is greater than 0 or equal to.
Yeah, that's what I was looking for. If we only use the portion of the graph that's greater than or equal to 0, if we only inverse that part, then it would have an inverse function. So if I only use that part, my inverse function would look like this. And we would have an inverse function at that point. So the reason why I bring this up, just to remind us about how we find inverses, how we tell if it has an inverse function, and then I wanted to talk about the restrictions. Because today we're actually doing inverse trig function. The next picture you have is the sine graph. The sine graph by itself does not have an inverse function because it does not pass the horizontal line test. So what we have to do is we have to restrict the domain to only use that portion. And the reason why we're choosing only that portion is because we have y values that are positive and y values that are negative within that range, within that domain. On the unit circle, I'm using from 0 to this pi over 2. That's the positives. And then from here to here is what? Right, this is from 0 to negative pi over 2. So on the unit circle, that's from here to here, only we're using negative pi over 2, not 3 pi over 2. So I have written the restrictions that we are using for sine is going to be from negative pi over 2 to positive pi over 2. I would encourage you to draw that picture because I feel like visually that helps those of us that are visual learners. This is the restriction for sine. It is also the restriction for cosecant because they are reciprocals of each other, so they're going to have the same restrictions for this. This is where I would use it. Here's an example. If I gave you sine inverse of negative square root of 2 over 2. Nope, that's positive square root of 2 over 2. If I gave you sine inverse, what am I asking for? You've done this before. What am I asking for? The angle. Perfect. I'm asking for where, at what angle, is the sine equal to square root of 2 over 2? That's what I'm asking. At what angle? Right, except for we're only giving radian answers. So pi over 4 would be the correct answer. But there's actually two places. It also works at 3 pi over 4. That's not in the domain restriction, so we're only going to give one answer.
If there's several that are within the domain.
There will be. So the domain is picked so that there is only one. Okay? So there will not be several. There will only be one answer. You just have to make sure that your answer is within, bless you, is within the domain. Yes, Michael.
Where'd you get the radical?
Say that again. Where do you get what?
Where'd you get the radical to? Like,
I just made it up.
oh.
That's the question, the example. So right here, you will also see something that looks like arc sine. That means the exact same thing as sine inverse. It's just a different way of writing it. It means the same thing. So it still means find the angle at which sine is equal to square root of 2 over 2. Those mean the same thing. No difference. All right, for cosine, we needed to pick cosine so that we had positives and negatives. But if I pick the same window for sine and cosine, then we'd have positive and positive. That doesn't work. So they pick from 0 to pi for cosine. So if I'm drawing my unit circle from 0 to pi, this is where cosine and also secant, that's the restrictions on cosine or secant. Because we have to have positives and negatives. And then tangent and cotangent are two different restrictions. Tangent, and I'm doing this in colors, so if you just write on pencil, you might not remember what you did before. Tangent is the exact same restrictions as sine. By the way, tangent is y over x, or sine over cosine. And tangent looks the same as sine. Cotangent Cotangent is x over y, which is cosine over sine. And cotangent and cosine have the same restrictions. So tangent has, and the restrictions are written right here for you too. If the pictures aren't helping you, they're written there. When you are ready to go on, turn the page so I know you're ready to go on. Drop. You must know better than the teacher.
No, that's not. I'm just,
Well, it's gonna get worse.
no, I'm just trying to understand. So like, if I spend time writing it down, I know what I wrote down.
These are graphs of each inverse function, and what you'll notice is that when we find inverses, we switch x and y. If you look at the x-axis and the y-axis, they're switched of what we've been graphing. See, the pi over 2's are up and down rather than left and right. So you just see that they're switched. That's just for your reference. All right, these are the examples that we like your assignment. Sine inverse of 1/2. That means where is the sine equal to 1/2? So I already have that sine of 30 is 1/2 memorized. I have it memorized. But I'm not saying 30 degrees.
5 or 6.
Okay, so sine, the restrictions are here. This is positive pi over 6. Cosine. Cosine restrictions are here. This is a negative. So it's going to be in the second quadrant. So I'm thinking to myself, where is cosine square root of 3 over 2? Well, that's a 30 degree, which is a pi over 6. But to get it over here, it has to be 5 pi over 6. Does that fit within my 0 to pi restriction?
Yes.
Tangent. Where is tangent -1? Well, where is tangent 1? See, this is what we have to have memorized. This is where it's going to go fast. And if you're not following, it's probably because you don't have these memorized. Tangent restrictions are first and fourth. Tangent is which? Tangent, I'm sorry, 1 is, -1 is a 1, which is pi over 4. But we need it down here to be negative. 7 pi over 4 does not fit within the restrictions. So it's got to be negative pi over 4. Remember, the restrictions for tangent go from negative pi over 2 to positive pi over 2. So 7 pi over 4 is that same place, but we have to give the negative pi over 4 answer instead. And secant. I don't have secant memorized. I do have cosine memorized. So what I normally do is I just change this to cosine and then reciprocate that value. These two things are equal to each other. So where is cosine square root of 2 over 2?
$45.
45. So it's pi over 4. Okay? The next section says arc. The directions are not different in this section, though. It just looks different. I don't know what the first question is, sorry. All right, so arc cosine -1, that means the same thing as inverse cosine -1. It means the same thing. So where is cosine -1? That'll be in the top half. Sorry, that's terrible. Picture. Okay, cosine is x over r. So to get -1 over 1, that can only happen here. At -1, 0. Pi. Pi over 4, cosine of pi over 4 is square root of 2 over 2. Okay, next one. Arc cosecant. So I would start by changing it to sine. I would do arc sine of what? Half. So where is sine of half? 5 or 6. Next one is arc cotangent. So I would change it to arc tangent first. You don't have to change it. I just think it's easier because I only have tangent memorized. I don't have cotangent memorized. So arc tangent would be negative square root of 3 over 3. Where is tangent square root of 3 over 3? Pi over 6, but this says negative. It'll be down here. That'll be a pi over 6 down there. So what is it? Negative pi over 6.
Opposite 30 is 1, is it?
This would be 1 over square root of 3. Which is square root of 3 over 3. And then arc sine negative square root of 3 over 2. So this is sine, and it's negative. It's got to be down here. Where is sine square root of 3 over 2? That's a pi over 3, and it's negative. When you are ready to go on, flip page over so I know that you are ready to go on. Okay, so the next section are compositions. We've done this kind of stuff before, where you do the stuff on the inside first and you use that answer to apply to the new function. So the first thing that we're going to do is cosine of pi. We do that first. Cosine of pi. What's the cosine of pi? Negative 1. Then we take that answer and apply it to sine. So the sine inverse of negative 1. Where is sine negative 1? Can it be 3 pi over 2?
No. It's negative 5 over 2.
So you're basically doing 2 questions in 1. Number 2, we do tangent of 3 pi over 4 first. Not quite. So once you find that the tangent of 3 pi over 4 is negative 1, then we do arc cosine negative 1. So where is cosine negative 1?
Why is tangent of 3 pi over 4 negative 1?
The picture would be there.
Yeah.
And that's going to give me a pi over 4 reference angle,
So 45.
which is 45.
So 1
Tangent of 45 is 1, but in the second quadrant it's negative 1.
45, 45 brackets, 1 bracket 2.
But this one would be negative 1, 1,
Yeah.
radical 2.
I got you. I see.
So where is cosine negative 1?
Pi.
Pi. Okay. All right, next one says, where is cosine negative square root of 3 over 2? That's the first part we do. Where is cosine negative square root of 3 over 2? It's got to be in the second quadrant to be negative. Is it a 30 or a 60? 30.
It's 60. No, 30. 30. Yeah.
All right, I'm sorry. Where is it?
It's a 30.
Okay, so if it's a 30, then what radian?
5 or 6. Which is 5 pi over 6.
5 pi over 6. If it's 30 degrees right here, then we're looking at 5 pi over 6. So we're doing tangent of 5 pi over 6. So then what is the tangent in the second quadrant with a reference angle of 30 degrees? What's tangent of 30 degrees? It's radical 3 over 3, but this is second quadrant, so it's negative. You see how this can get confusing? Maybe a little bit. Then we've got cosecant, inverse, -2. So where is sine -1/2? Right, sine is -1/2 at -π/6. And then we have to find the sine at -π/6. What is that? Jordan? Close. -1/2. You see how these just kind of undid each other a little bit? Because inverse and the function, they undo each other.
Sine -π/6 would be something.
Yeah. Why don't you try the next one? It says it's tricky. It's not really tricky. You try the next one. Huh? No. That's the only reason why it's tricky. If you do it step by step, it's not. This is not a contest to see who can show the least amount of work. This is get the right answer. So you need to draw a bunch of things, draw a bunch of things. It might take you twice as long to try to do it in your head. You need to draw the picture, draw the picture. That doesn't have a restriction. That doesn't have a restriction. Only when it's part time. That's when restriction happens. When it's finding the angle. Here's your thing. So there's no restriction on that. -3π/4 is here. Did you get it here? So I've got a π/4 reference angle, but it's in the third quadrant. So the sine of this angle right here is what? What is it? I can't understand you. You guys are afraid to say the wrong answer. I get it.
Is it -radical/2/2?
Yeah, it is. So now, arc sine means where is the sine? Negative, (2/2), but within the restriction. So it's not going to be the same place because that's not in the restriction. Sine has to be from here to here. So we want the negative to be there.
-π/4.
-π/4 would be the final answer. All right, and then this one, secant, that's the same thing as cosine, but flip it. So this would be √3/2, negative √3/2. So I need to find where cosine is negative √3/2. It should be over here. And I think it's 5π/6, right? And then you do the secant at 5π/6, which is finding the cosine and then flipping it. So the answer is -2 radical 3/3. If you do not know how I got an answer, you can ask while we do the notes. If it is a matter that you don't have your unit circle memorized, you're probably going to seem lost because you don't know where I'm getting these numbers from. Do you not have your unit circle memorized? That will come with practice. So we have one more section to do.
Why was it radical 3 over 2?
Well, cosine at this angle is square root of negative.
I'm talking about the one from the original one. Why did it go to radical 3 over 2?
If I flip it, then it would be 3, negative 3 over 2, radical 3, and then we have to rationalize it by putting radical 3 over radical 3. Gonna go this way. It would be 2 times 3 on the bottom, and the top would be 3 radical 3, and then those would cancel. Put the square root of 3 over 2. But I have my unit circle memorized, so I knew it was going to be that already.
You have to cross it out like that, because if you multiply it out, it'd be 6. It'd be 3 radical 3 over 6.
And then you have to reduce that.
It should be 1 over 3 over 2. 2? Okay.
Same. Yep. All right, the last one say we do not need the unit circle for these because they are not on the unit circle. So you have to draw the picture. So sine inverse 3/5. So we're trying to find where is sine 3/5. One thing I do know is that it's the first quadrant. It's positive. So I know it's the first quadrant. I also know that sine is y over r. So I know that my y value is going to be 3 and my r value is going to be 5. All I need to know is where it's located and then be able to find the cosine at the same place. I don't have to know that that is a 37.1 degree angle or whatever it is. I don't have to know that. All I have to know is what the cosine is at that same location. So what's cosine? X over r. Do I know x? 4. So cosine would be 4/5. So I found where sine is located, then I found cosine at that same location. So example 8. We need to know where cosine is negative 5 over 7. So where's cosine negative? Which quadrant?
2.
Quadrant 2. So I'm going to draw a triangle that has my x value being negative 5 and my r value being 7. And then I'm going to find tangent at that same place. Tangent is y over x. So I have to know y. How do I find y?
Egg right there.
Mm-hmm. A squared plus b squared equals c squared. So I use my Pythagorean theorem, and I get square root of 24, and then I simplified that radical, got 2 radical 6. So that's my y value. And so the tangent of this triangle is going to be y over x. So I'm going to have negative 2 radical 6 over 5. Why did I not write it over negative 5? Who can tell me why it's not over negative 5? Don't leave a negative in the bottom, right. So I just move it out front. Okay, last one. Last one. Cotangent. I don't know cotangent very well, but I know tangent. Tangent is 1 over 4, which is y over x. And it's positive, so which quadrant? First quadrant, where y is 1 and x is 4. And I need to find cosecant, which is Well, sine is y over r. So cosecant is r over y. So I need to find r. Pythagorean theorem. So we get square root of 17 for our radius. And then we do r over y. Lots of little steps you're going to have to go through yourself. You have to get your unit circle memorized yourself. I can't do that for you. So start on your assignment. Check answers with me. I'm going to walk around and help you where you need it. It's the worksheet that is attached. I've also put the worksheet on Canvas already, and the video will be on Canvas in just a moment.